Hi students. Today again we are here. We'll be going through the topics like transmission media, and I believe I've made a slide of presentation of 52 slides. So I think we'll be covering this in 2 hours. So let us start the session. So it's about like transmission media. So basically, what we can say about the media. So basic function of media is it has to like carry flow of information in the form of bits. Now we are talking about the digital data and how it can be transferred. It can be transferred via LAN cable and in a copper-based network in which bits will be transmitted as an electrical signal. It can be a fiber-based network where bits can be transmitted in the form of light pulses. It can be like media considered to the layer 1 component. We are talking about the physical layer. So basically what happens is when we are transmitting data, so it is it gets traveled across the physical path between the transmitter and the receiver. Transmitter you can say at the center side and receiver at the destination point. It can be wired as well as wireless, and the communication, majority of the communication takes place in the form of electromagnetic waves, and the characteristics and quality of data transmission are determined by characteristics of medium and signal. That's important. And in wired media, medium characteristics is more important. Yes, absolutely. When we are talking about a wired medium, so like we can physically see the data is flowing through some cables, some wires. So yes, medium characteristics becomes very important. Whereas if we talk about the wireless media, so like it is the signal characteristics that are important. So this needs to be like taken care of. You can note this point. Okay, so when we are talking about transmission media, so I think all these points we have covered in the previous slide. So let's go on with the next slide. Yes, this is one data. You can see that. So basically, it's it's a sum of data of various types of media, and in the other two columns, the maximum bandwidth is depicted here and their distances. So right from the coaxial cables, then we have got twisted pairs, then multi-mode, single mode, and other technologies, and wireless also. So all these data is there. So we'll be we'll try to cover each and every to a certain extent. So this is just a summary. Okay. So this is one electromagnetic spectrum which is given here. So you can see the spectrum is given for this power and telephone, and radio one, the microwave, the infrared, and the visible light. And visible light is of like same frequency as of the optical fiber. At the same time, we have this twisted pair also, coaxial cable, radio, FM, radio, TV, and satellite transmission. So what we can see is both the things are mentioned over here, the frequency as well as wavelength, and different types of mediums, different types of waves are discussed here. So we can see the one with the minimum frequency or one with the less frequency has got a higher wavelength, and at the same time the one with the higher frequency has got a very less wavelength. So in a nutshell, what we can say is, at least this diagram is depicting, the frequency is inversely proportional with the wavelength. The more the frequency, the lesser will be the wavelength, and more the wavelength, lesser will be the frequency. So these are basic limitations when we are transmitting some data. So these are the some basic limitations we have to deal with. You can see this is like attenuation. Attenuation we have seen in the last lecture. What happens here is due to attenuation, the signal strength drastically reduces. So in order to nullify that effect, what we do is we use amplifier. We do amplification. When it comes to distortion, distortion is something, it is even more serious. Your signal gets D-shaped. So when I'm talking about D-shaping, its phase gets changed. So phase in between, if it gets changed, like it's a serious thing. It shouldn't happen. Like whenever we are talking about an effective communication, so we generally think in that scenario where the whatever has been transmitted should get received in the same manner at the destination point. And if we talk about noise, noise is something, it is it is additional data in comparison with the original data that you are sending. So like now you are having in noise the original data, and plus you are also having some additional data, and we are like categorizing it in noise, and there are like different types of noise are there: crosstalk, echo, impulse noise, intermodulation, and thermal noise. So these are the design factors when we are like dealing with transmission media. Yes, bandwidth is very important. The greater the bandwidth of the signal, the higher the data rate you can achieve. So bandwidth has to be sufficient for effective communication. There has to be sufficient bandwidth. Otherwise, like there will be a lot of traffic, delays will be there. So yes, bandwidth should be decent enough. Okay, then you have got transmission impairments. This is something you have to look for. It is always a good practice to minimize the transmission impairments. However, still having said that, there can be this is totally impractical thing that you will be having zero transmission impairment. So this is not possible. But yes, we have to minimize that in order to have this efficient communication. Yes, interference, it has to be like minimum. We have to make sure that there are no overlapping frequency bands that can distort our signal, or on a maximum on a higher side, like they can wipe out the signal. So, and number of receivers, yes, attenuation and distortion may get affected by the number of receivers too. Okay, so this is like a broad classification of transmission media. When we talk about the transmission media, we categorize into two categories. Like one is the guided media, another one is unguided media. Like when we are talking about the guided media is something somebody is guiding it. So like there has to be some physical presence, like somebody who is using the conduction is there. Somewhere or the other, it has to be conducted by something. And when we talk about the wireless, obviously it is unguided. You cannot see physically what's going on. So there is no presence of cable, maybe twisted pair, coaxial. We'll be seeing that in the forthcoming lectures. Yes. So these are like two categories. One is guided, another one is unguided. For guided, we have this twisted pair, coaxial, and fiber optic cables. Okay. So what we say about the wire conductors, yes, when we are talking about the guided ones, so they are of three types: simple conductors, twisted pair, and shielded ones. Large installed base, yes, there has to be large installed base. The cost is reasonable when we are using it. Relatively low bandwidth is what we are able to have here. And recently what we have also seen is close to 100 Mbps we are able to achieve. Yes, these are susceptible to external interference, these wired ones, and they can transmit both analog as well as digital signals. Amplification is required after every 5 to 6 kilometers for the analog signals, and when it comes to digital signals, this becomes 2 to 3 kilometers. So when we are talking about the twisted pairs, yes, they are the oldest one, the least expensive, and most commonly used media. They are the pair of insulated wires, they are twisted together to reduce susceptibility to interference. See, this is you can this is something to ponder upon. Why there is they are twisted? So they are twisted in order to reduce the interference. So this is to be noted. And yes, these are few details mentioned over here, like this 2 to 3 kilometers repeater one we have already seen. So this is the exact example of twisted pair. You can see the diagram. In this way, there are two wires, they are twisted with each other, and some common specifications are given, like high speed, yes, 10 to 100 Mbps speeds you can expect here. and it's like fast Ethernet. It uses token ring topology. You must be recalling it. We have earlier seen when we discuss the topologies. There are many topologies: bus, mesh, star. So there is one more category of topology, that is ring topology. So what we do is we distribute tokens here, and in this way communication goes. Okay, so there are two types of twisted pairs. One is the shielded one, another one is unshielded one. So the basic difference between these two twisted pair is, if you talk about the shielded twisted pair, you get one additional sort of layer, and that is actually the shielding that is missing in unshielded. That is why the name is shielded and unshielded. So we can see this in the diagram. So these are the ratings of twisted pair. These are the different categories. Like these days, I should say, Cat6 are very common. Like even in our facility at our campus, at our university, we have this Cat6 cables, the normal Ethernet cables that you see. This is it, right from category 3, category 4, and category 5. So now we are here in the category 6, and obviously when we are comparing it with the category 3, definitely we are able to achieve a better performance in cat 6 cables. Yes, but having said that, they are bit expensive in comparison with the other. Okay, so these are the advantages of twisted pairs. They are inexpensive, they are readily available. Yes, they're very easy to install also, they work upon, and they are flexible. Yes, lightweight. Disadvantages, yes, despite of the fact that we use it in a twisted pair, still interference noise is there. Attenuation is yes there, as we have seen in the earlier slides, and relatively low bandwidth. Yes, so this is the diagram for this twisted pair cables. You can see these two wires are twisted together, and inside individual wires we have this solid copper conductors which are responsible for the transmission. Okay, so this is effect of noise on parallel lines. If we'll be using the, see, now the question goes, why are we using parallel lines, or why are we using it in a twisted pair, why we are using it? Instead we can go for the parallel lines. So here is the answer for this. If we'll go via this way, so what happens is a lot of noise is there. In one direction it is 16, the other is 12. The net we have got this noise effect as 4. But what we'll do is, when we'll have it in a twisted manner, so as you can see on both the sides, it gets nullified, and the total noise effect is 0. So this is this is our effort to make it in a twisted pair, just to decrease the interference and the noise. This is we were talking about in the earlier slides. This is the concept of unshielded one. So it's very simple. This is a cable, and inside the cable you can see there are multiple twisted pairs, to be precise 5, and yes, these are wrapped with the help of a plastic cover, as you can see in the diagram. Then what we have in shielded is, in shielded we have got this is the earlier twisted pair. Inside there is a copper wire, and now if you compare both the diagrams, so here plastic cover is there, it was there in the unshielded one. This metal shield, it provides extra layer of shielding. So this is the difference between shielded and unshielded. Now we are switching to another wire transmission media. So that is coaxial cable. It's the most versatile medium. Like you must have seen in earlier days, when we used to have this cable TV connection, the local cable operators used to provide us. So there was that black colored cable. Still we have in our homes, the DTH connection is there. So we have this thing. So we still use that. So noise immunity is good. We can say it is better than the twisted pairs. Yes, high channel capacity. We are able to reach maybe 100 Mbps very effectively. Yes, and they also need a repeater and amplifier. like the one we have studied in twisted pair. Twisted pair were also using this repeater amplifier. It has got an inner conductor surrounded by a braided mesh. Both conductors share a common center axial, hence the term is coaxial. Since like it's the centric sort of a shape, centric sort of a figure which is in the form of axis, so that is why the name is axial and sharing one common core. So we'll see in the next slide. Yes, this is what we were talking about. This is like signal in the grounded wire. So you can see again this plastic covering is there here also as it was there in the twisted pair. Yes, this is the outer covering, outer conductor braided one, and this is the insulating material, and inside that we have got a core. I like introduced this term core in the previous slide. So center conductor is shielded from external interference signal. So that is the reason we have to look for interference here also. When we talk about the properties of the coaxial cable, yes, it provides better shielding, allows for longer cables and high transfer rates. Like even this is feasible 2 Gbps. These are the simple data. This is mentioned here. They are less susceptible to interference. However, we cannot say there is zero interference in coaxial, but yes, in comparison to twisted pair, it is very less. Nowadays, like even these are not in that use. They are like replaced now by the optical fiber. And one disadvantage of using these is they are bulky. So when we are saying they are bulky, yes, they are like as far as their weight is concerned and like this in comparison to twisted pair, their weight is more. And yes, high attenuation is something we have to look for, because when we were discussing twisted pair, so like a repeater or amplification was required in every 5-6 kilometers and every 2-3 kilometers, but here we are using it in every 1 kilometer. So when we are saying we are using it in every 1 kilometer, so it's like attenuation rate is quite high, and it makes this thing more expensive, because again for every kilometer, if you have to like look for the attenuation thing, so definitely you have to like apply more and more repeaters, amplifiers. So this is again like an expensive affair. So when we talk about the wire transmission medium, one more we can study, that is the optical fiber. They are very flexible, very thin, and very small in size. And this is like very pure glass plastic fiber, capable of conducting optical rays. Yes, they have a very excellent bandwidth, very high noise immunity. Yes, noise is something like is taken care of at this place. Optical fiber does that, and they are resistant to electromagnetic interference even better, like noise and interference both are taken care of, and they does not radiate energy, cause interference. Yes, they are very light, and repeaters are required, but like in comparison with twisted pair and coaxial cable, it is very less. Like you can see only tens or maybe 100 kilometers. So after 100 kilometers, if you are requiring repeaters, so I think it's good thing. So very difficult to tap. Yes, security point of view, like one is like it is not easy to suspect the data. Like if somebody who is like a mischievous activity, or maybe somebody who is interested in someone other's data being transmitted, so it's not that easy. And what it does is like it requires a light source with injection laser diode or light emitting diode. So these are the technical things. You can see the diagram. There is one core thing, then there is a jacket, and finally there is a cladding also inside that. And this is the process, like how it's like data gets transmitted here. It gets transmitted in the form of signals. Sorry. So optical fiber is there, need optical electrical interference. It is like more expensive than the electrical interference. So this is like the phenomena. You must go through this. This is like important to understand. This is the basic principle for optical fiber transmission, based on the principle of total internal reflection. Yes, like there is an incident light. Optical fiber, when we are talking about, like it deals with the light. So traveling of light signals. So whenever an light is incident on some surface, say for example, it is like being incident or at an angle of A. And then obviously there are two options. Either it can get reflected or it can get refracted, or it can get reflected as well as refracted. So this is like the interference between two media A and B. So what we are like seeing here is we are looking at the two examples, like two scenarios we are seeing. If this refracted angle is greater than the reflected angle, then it is a higher optical density than medium A. And if that is this is the case, like if the reflected angle for the light incident ray is greater than the refracted one, then this is the scenario. If alpha is less than a certain critical angle, there is no reflected light. All the light is reflected. This is what makes fiber optic work. So we should like focus on this. The light should be reflected. Then only we'll be able to perform the job of this optical fiber. Like now, physics gets involved here. So refractive index material. This is the formula. You can note it down. Speed of light in vacuum divided by speed of light in material. So light is bent as it passes through the surface. This we have discussed in the earlier one. Where the refractive index changes. Obviously, when it will hit the surface, the light will, the speed will change, and so does the refractive index. So this bending depends upon the angle. Yes, we have seen in the earlier slide, there are two angles involved here. One is the reflected one, another one is the refractive one. Frequency does not change, yes, but because it slows down, the wavelength gets shorter. Yes, frequency does not change, but wavelength gets shorter. So in case of fiber, refractive index of core should be greater than the refractive index of cladding, thereby causing internal reflection. So this is the diagram for fiber optic layers. Consists of three concentric sections. The core is there, the plastic cladding, and the plastic jacket is there. So these are the modes of fiber. Fiber consists of two parts, like there is one glass core and another one is a glass cladding with a low refractive index. Light propagates in one of three ways depending on the type. So these are the three types of this index fiber. So one is like multi-mode stepped index fiber, in which both core and cladding have different but uniform refractive index. This should be noted down. And it relies on total internal reflection. Whereas if we talk about this, here only the core has variable refractive index and it's like narrow pulse width resulting in higher bit rate. So bit rate is higher here. And this is again one parameter for single mode fiber, where we are like able to get a good bandwidth. Width of core diameter is equal to a single wavelength. So this is again, if you talk about the optic fiber, this is the categorization. Mode is divided into two, categorized into two further categories, multi-mode and single mode. And in again multi-mode, we have this step index and graded. So these are like fiber optic types that we have already seen. You can go through this. There is like simple one line statement is there. In multimode, the reflective walls of the fiber moves the light pulses to the receiver. Yes. In multimode graded one, it acts to refract the light towards the center. And here the light is grounded on the center of an extremely narrow core. So these are the types of optical fiber. Single mode, also known as monomode. Only one mode propagates, higher bandwidth than multi-mode, longer. So now these are the comparison also given. So you can note this down. For multi-mode, again, it propagates fiber, different angles are there, transmission arrive at different times, modal dispersion are there, likewise. So this is like even for diagrammatic purpose, it is shown here. Fiber optics like seems to be more of like very simple one. That's the name given, fiber optics single mode. And this is like multi-mode graded one, and this is like multi-mode step index, step by step. It is moving. So this is again one diagram, step index, graded index, and the single mode. And for every diagram, input and output pulses are also shown. So you can note it down. And these are the advantages. Yes, this is even more important when it comes to exams. Like with the perspective of exams, like advantages, greater capacity, yes. Smaller size and lighter weight, yes. Lower attenuation, yes. Immunity to environmental interference, yes. Highly secure due to tap difficulty, yes. But there are certain disadvantages also involved. It is expensive. Like for a very short distance, you'll prefer going with this twisted pair, or you'll prefer coaxial cables, not the optic fiber. And yes, because there are a hell lot of like this physics and other things involved, so it's like a skilled person should be involved here for the handling of this thing. And yes, this is again one of the biggest disadvantages, like in between, when you are already using an optic cable thing, and in between you want to add some participants, you want to add some nodes, so this is not possible. So this is like a small diagram. You can see there again the core, cladding, and jacket is there, and the one outer layer, extreme outer layer, is called as sheath. So you can see this diagram. We have earlier seen this diagram. So now the comparison is also there. Fiber versus copper. The pros are the positive sides are bandwidth is higher, lower attenuation, immune to electric. This we have already seen. And again, this is we have seen like a skilled person should use this. They are expensive and inherently unidirectional. So this is, we have seen. So we'll be seeing students wireless unguided media transmission in next lecture. So thank you. Thanks a lot.